A WordPress site can reject an anonymous request at one layer, then accidentally route that same request into code that assumes the caller was already trusted. Add a SQL injection behind that confused route, and two separate bugs become an unauthenticated takeover path. That chain is called WP2Shell. It is being exploited, so this is a patch and investigate problem, not a story to save for later. WordPress released emergency fixes on July 17, 2026, and enabled forced automatic updates for affected versions. 4 days later, CISA added both flaws to its known exploited vulnerabilities catalog based on evidence of active exploitation. In the next few minutes, you will see where the trust boundaries fail, which versions need which fix, and how to handle a site that may have been exposed before it was patched. Start with the normal path. A request reaches the WordPress REST API. The batch endpoint carries several subrequests, checks whether each route is allowed for batch use, then dispatches it to a callback. The callback turns accepted parameters into a WP_query database request. Each box trusts the previous one. The router assumes the route it checked is the route it will run. The callback assumes only an authorized request can reach it. The query builder assumes author__not_in has been safely typed and prepared before SQL. WP2Shell breaks those assumptions. First, CVE 2026-63030 desynchronizes route validation and dispatch in the REST batch endpoint. A crafted subrequest can be checked as one route but sent to an unintended callback, bypassing its normal batch restriction and input sanitization. Second, that callback feeds attacker-controlled author__not_in data into affected WP_query code. CVE 2026-60137 does not properly sanitize and prepare the value, so the attacker can alter the database query structure. Together, route confusion makes a restricted SQL injection sync reachable without authentication. Reports describe malicious administrator creation or, under suitable database and file system conditions, a web shell. Those are possible paths, not a universal one-step payload. The version matrix matters. WordPress 7.0.0 through 7.0.1 has both flaws. Update to 7.0.2. Version 6.9.0 through 6.9.4 also has both. Update to 6.9.5. Version 6.8.0 through 6.8.5 has the SQL injection, but not the full route confusion chain. Update to 6.8.6. WordPress says versions earlier than 6.8 are not affected by these two CVEs. Do not treat automatic updates enabled as proof. Confirm the live version in dashboard, updates, or with WP core version. Forced updates reduce exposure, but a failed job, hosting policy, or file system permission can leave a site behind. The release tells administrators to update immediately. Checking the installed version closes the assumption gap. Take a fictional training site, courses.example, running 7.0.1. The administrator inventories the live version, updates to 7.0.2, and verifies it. Good. The vulnerable door is now closed. But the REST API was exposed during an active exploitation window, so the job is not finished. This is an illustrative response walkthrough, not a report about a real site. Next, review requests to the batch endpoint. Inspect recently created administrator accounts and unexpected recent files, especially writable web and cache paths. Rotate WordPress, database, hosting, and API credentials where exposure is plausible. If integrity cannot be established, recover from a known good backup. Independent reporting observe new administrators and a web shell under a cache path, which is why patching and compromise triage must be separate workstreams. A WAF can buy time against known request patterns, but signatures can miss new variants. The vendor update is the primary fix. And CISA's KEV listing proves evidence of exploitation, not how many sites were compromised. Do not turn telemetry into an invented victim count. The reusable lesson is about canonicalization. One component checks an interpreted request. Another component later uses a differently interpreted request. That scene lets an attacker inherit trust they never earned. Security checks and execution must agree on the same canonical route in the same typed input. Then test the composed path, because a moderate-looking SQL bug and a routing bug can combine into something much worse than either row suggests. Remember the response card: inventory, patch, verify, hunt, then rotate or recover. Close the door and check whether anyone is already inside. For practical cybersecurity training, use the course link below.